Hi, and welcome to Poly Packet tutorial number 2. We're going to be looking at polynomials and subtracting them. So there are two different ways we can do a problem like number 1. We can bounce off the sign, and bouncing off the sign looks like this. 3x minus 6x equals, well, if I put 3 minus 6 in my calculator, I'm going to get a negative 3. So that's negative 3x. And then we'll bounce again with the 7, and we'll say 7 minus 5 equals 2. Now, what's the second way you can do this? If you don't like bouncing off the minus sign, then you can just change this problem. So I'm going to go backwards and do it the second method. So I could rewrite this problem like this. The first polynomial, I'm going to write the same. See how there's a minus sign here? Some of you don't like that. You know what? Just change it. But if you change that minus sign to a plus, that means that every other term that comes after that minus sign, their signs have to change. So that means that this was a positive 6x, not anymore, we have to change it. This was a positive 5, not anymore, we have to change it. And now, if you do that, you don't have to bounce off the minus sign because there isn't a minus sign. Now you just have to combine like terms. And we would say 3x plus negative 6x is negative 3x, and 7 minus 5 is a positive 2. So either way you want to do that, you can use either method. So for number 2, I'm going to go ahead and bounce off, and then number 3, I'll do it our second method. So here we go. I'm going to bounce off. I'm going to say 5x minus 4x. Well, that equals 1x, just like 5 cookies minus 4 cookies, just 1 cookie. And then we'll have negative 3 minus a 1. If we put that in our calculator, we'll get a negative 4. So x minus 4. This next one, I'm going to rewrite it. So once again, you get to look at the second method again. If I don't like a minus, I can change it. But that means that I have to change every sign of each term that's after that sign I changed. So if it's a negative 6x, no more, it's positive 6x. If it's a positive 8, no more, it's a negative 8. Technically, what we're doing is we're distributing the negative sign. Also, we could be factoring out a negative sign. But for the reasons why we're allowed to do it, you just know that you can use this method to do it. All right, 8x plus 6x, that's 14x. 7 minus 8, that's negative 1. If you're wondering if we would get the same answer using the first method, let's do the first method real quickly. 8x minus a negative 6x gives me a 14x. 7 minus an 8 gives me a negative 1. So either way, with either method, we get the same answer. Okay, we could also use this when we were subtracting before. In the first 3 problems, we had binomials, right? Polynomials that just have 2 terms are binomials. So number 1, we had a binomial minus a binomial. Well, we could also do it for polynomials that have 3 terms. A polynomial with 3 terms is a trinomial. So what we've got here is a trinomial minus a trinomial. So we can bounce off. We can say 3x squared minus 6x squared equals negative 3x squared. Let's switch up the colors. 7x minus a 5x is a 2x. And 10 minus a 3 is 7. Note, if just like 7 was a positive 7, I had to put that plus in front of it. I just can't put the 7 right next to the 2x, because then that looks like I'm multiplying it. So remember that sign. Let's go ahead and bounce off 5x squared minus x squared. That's going to leave us with 4x squared. It's just like 5 cookies minus the cookie leaves us with 4 cookies. If we take negative 13x minus 8x, well, that's going to give us what? Negative 21x. And if we do a 4 minus a negative 10, if I put that in my calculator, 4 minus a negative 10, that's going to give me a positive 14. All right, we haven't used the second method in a while, so I'm going to go ahead and do number 3. Instead of bouncing off the negative sign or the minus sign, I'm going to go ahead and use the second method. So I'll rewrite the first part, the first trinomial, and I will change the minus sign into a plus, and that means I'm going to change every single sign that comes after that. And then we don't have to worry about bouncing off. Not that we would be worried about it, but in some ways it makes it easier. So 8x squared plus 6x squared is 14x squared, right? This plus this. 7x plus 8x is 15x. And 2 plus 2 is 4. That was kind of fun saying that, kind of like elementary school. 2 plus 2 is 4. All right, sometimes subtracting gets a bit crazy. And if we look at number 1, what's crazy about it is that it's not in the same order. So there's a couple different ways you can do it. The first way is just to be observant and notice that when you're looking at the negative 4x and you're bouncing off the minus sign, who do you bounce off to? Well, you've got to bounce off to a like term, which would be the 7x. So this is our first method. We could say negative 4x minus 7x. If we put negative 4 minus 7 in our calculator, we get a negative 11. So it's negative 11x. And then we can bounce off negative 5 minus a negative 1. If we put that in our calculator, we'd get a what? A minus 4. So here's our answer. Now, you want to know a second method to do it? We're going to do a second method over here. I'm going to rewrite the problem. If you like that first method, great, use it. I'm just going to show you a second method and see if you like that better. Once again, we can use our method of if you don't like the minus, you can write it as a plus, but that means you've got to change everybody's sign, every term sign after that. The second thing you can do, if you don't like that this is not set up in standard form, you can rewrite the first and then rewrite the second. You can flip it around. Now, this second method takes a lot more steps, but when you do these steps, it might allow you to make more sense out of this problem. So then we've got negative 4x plus negative 7x, which gives us the negative 11x. And then the negative 5 plus the 1, which gives us the negative 4. Same answer, different method. All right, I'm going to use the first method to do number 2, and I'm going to use my method of observation. I'm going to notice this 5x squared is not the same thing as this 2x cubed. They are not like terms. I can't say 5x squared minus 2x cubed. Nope, they're not like terms. And so this is a problem. Some people like to do this. If there's no x cubed term, they like to rewrite this first part as this. There are no x cubed terms. They just rewrite it like this. They rewrite the whole problem. That's probably the best thing to do if you want to understand it clearly. So let's do it that way first. There are always shortcuts, and if you want to use a shortcut, you can too. Now, though, we have something to bounce off of and connect to. So if we have a 0x cubed here, we're going to say 0x cubed minus a 2x cubed. If I put 0 minus 2 in my calculator, I'm going to get negative 2x cubed. And then I notice when I move to my 5x squared, is there any 5x squared over here in this binomial? No. So it's just 5x squared. We don't subtract anything because there's not another x squared to subtract. So 5x squared minus nothing, because nothing's there to subtract, it's just 5x squared. Then we move on to our next term, and our next term is the minus 3x. Is there in this binomial a term with just an x? No. So we're not going to subtract anything. We're just going to have a minus 3x because there's nothing to subtract from it. And we'll move on to our last term. We have an 8, and yay, we have a term to subtract from it, 8 minus a negative 4. If we put that 8 minus negative 4 in our calculator, we get a plus 12. So like I said, subtracting can get a little bit crazy, a little bit tricky, but what you need to do is just slow down and get it right. All right, mix it up. So here we're noticing that we've got a binomial plus a trinomial minus a binomial. And we have a plus and we have a minus. So this one, the best way to do it might just be to rewrite the last part of it so we can keep it all addition. We could rewrite it as 5x squared minus 8 plus, I don't really need the parentheses, but I'm going to write the parentheses anyways because we haven't talked about that. Okay, I'm going to change the minus to a plus, but that means everything that comes after the sign that I changed, their sign has to change. So I'll have a minus x and a plus 5. And then once we do that, it's just about seeing how many like terms we can combine. So here we go. I see a 5x squared. Is there another 5x squared? Yep, I'm sorry. Is there another x squared? Yes, there's a 3x squared. Is there one over here? Nope. 5x squared plus 3x squared, that equals 8x squared. And we're done with those. Now, I see right here, see how that's a negative 8? That's not really the next term we want to deal with. We want to, well, how about this? We'll deal with it. Let's just go ahead and deal with it. Changing my mind on the spot. Okay, what other like terms do we see? We've got a negative 8 here, we've got a positive 4, and we have a positive 5. If you put that in your calculator, go ahead and do it. Negative 8 plus 4 plus 5, and it's going to give you a 1. We'll worry about putting this in what we call standard form in just a little bit. All right, so we took care of the 5x squared, we took care of the minus 8. The next term that we have left is this minus this negative 7x. We've got a negative 7x plus another negative x. Now remember, when there's not a number there, it's a 1, so that's a negative 1. If you put negative 7 plus negative 1, or if you put negative 7 minus 1 in your calculator, you're going to get a negative 8x. Now, if you wrote this on the test, we would give you credit, but just know that if you were doing a multiple choice test, let's say the EOC, the end of course exam, you wouldn't find it in this form. You would find it in standard form. And what standard form means is the term that has the highest exponent, which would be 2, comes first. The term that has the next highest exponent, which would be minus 8x, because its exponent is a 1, we just can't see it, comes second, and then so on and so forth. And then 1 comes last because it doesn't have a variable, doesn't have an x. So this is how to write it in standard form. All right, I'm going to do the same technique with the second one, just because I think it's the most straightforward way to teach it. If you can see some shortcuts, use them. But I want to give you something that can work no matter what. So here we go. I see this minus and I don't like it. So I'm going to go ahead and rewrite it so I don't have to deal with bouncing off. So here we go. This part stays the same. But this minus, if I change it into a plus, that means everything that follows it in the parentheses, and I should have said that from the very beginning, in the parentheses changes. So the negative 2 becomes a 2, the 9x becomes a minus 9x. Now, see this plus, the rest, that doesn't change. The only thing that changes is what comes after the changed sign in the parentheses. So now we're just going to gather like terms. Let's have fun with it. I'm just going to look at the first term that I see moving from left to right. I see that I have a negative 8x. And I can go ahead and combine that with a negative 9x. If I put negative 8 minus 9, or negative 8 plus negative 9, I'm going to get the same answer, with a negative 17x. So I'm done with those. The next term I come to is this minus 5, this negative 5. I have a negative 5 plus a 2 minus a 1. Go ahead in your calculator, put negative 5 plus 2 minus 1, and you should get negative 4. And then what do we have left? We just have one term left that we haven't used, and that's this plus 4x squared. Now, technically that's right. As I'm teaching this, I realize we do have some multiple choice problems on this test coming up, so you're going to need to remember how to get something in standard form. So who has the highest exponent here? 4x squared. That goes first. if we're going to put something in standard form. The next one with the highest exponent is the negative 17x, because that's x to the first power. So we're going to write it second. And then negative 4, it actually does have an x that we can't see. It's x to the 0 power, but we'll talk about that later. This is the correct way to write it. That's written in standard form. And that's it. If you need to review any part of this tutorial, go ahead and do so. Otherwise, move on to your Poly Packet, and thanks for joining me.